on similar right triangles and the geometric mean. So first of all, when you hear the word mean, what do you think of? What do you think of when you hear the word mean? Someone who's ornery or mean or difficult, right? Okay. Or the average. The average is the mathematical one that we typically think of. So if I ask you to find the mean of 3 numbers, what would you do? Add them up and divide by 3. The problem is that mean is the arithmetic mean. What we're learning about today is the geometric mean. So we don't want to confuse the arithmetic mean with the geometric mean. Okay? The geometric mean of 2 positive numbers is the number that is multiplied by itself to get the product of the other 2. Okay? So the geometric mean of 2 positive numbers, a and b, is the positive number x such that a over x equals x over b. So this is what we're writing in our first box. A over x equals x over b. So if x is the geometric mean and we want to find it, we simply make the a and the b, the 2 numbers that we're finding the geometric mean of, be on the diagonal of each other in 2 fractions. And we put the x on the other diagonal in both places. So a over x equals x over b. So far so good? Okay, now let's put some numbers in place. So if we want to find the geometric mean between 2 numbers, I'm not sure why this isn't going. Okay, between 4 and 9, your a is 4 and your b is 9. So set up the proportion for me. So Jared, what is your fraction? What does your proportion say? Four over x, careful, equals, so remember it was a over x equals x over b. So if it was 4 over x, then we need x is still up here, right? The 9 gets to be in the basement. 9 x over 9. So far so good? It says a over x equals x over b. The x's have to be on the diagonal from each other, and the a and the b are on the diagonal. Now, how do we solve a fraction equals a fraction? We cross multiply, okay? So when you cross multiply, what do you get? 4 times 9, which is 36. So 36 equals x squared. Good. So write 36 equals x squared. And how do we get the x all by itself if it's being squared? We square root it. So we get to be lazy in geometry, and we get to square root it and call it a positive 6 and not talk about the negative 6, because the geometric mean is always a positive number. And in geometry, we're always dealing with distances, and those are always positive numbers. So algebra 2, you're going to, when you square something or take a square root, you're going to have to think about both of those solutions, positive 6 and negative 6 as answers. All right, everybody got 6? All right, here's your next problem. Find the geometric mean between 3 and 15. Write it down. What's your proportion going to say? Put the proportion down. We don't want to have decimals. So if we have an answer that doesn't come out nicely like the 6 did, we want to simplify it. Find it in simplified radical form. So when we set this up, we ended up with 3 over x equals x over 15. And so x squared was 3 times 15 is 45. All right, is there a perfect square in 45? 45 is divisible by 5 because it has a 5 at the end, right? 5 times 9 is 9 a perfect square. So what comes out? Yep, 3 square roots of 5. And if you don't remember, you can always use your cake method, right? To figure out what the perfect square is. Find your pairs, circle them. The pairs come out as a single, and your other one stays inside. Okay? All right, last example of these. 2 and 10. Yeah. But that doesn't help me. I need to see that you know how to do this. All right, Skylar, what was your proportion? What did it say? Very good. 2 over x equals x over 10. So when we cross multiply, x squared becomes 20. Is there a perfect square in 20? So if you think about it, it's got 4 and 5. Is 4 a perfect square? So when the 4 comes out, it becomes a 2. And what stays inside? Yes. So if they come out perfectly, great. But if they don't, you get a decimal in your calculator. We need to simplify those radicals. And that will help you in Algebra 2 as well, a crucial skill for Algebra 2, and also on your ACT. Okay? So questions about geometric mean. All right, so you have a total of 8 problems that are just geometric mean. Very simple problems. You should be able to knock those out in a hurry. Okay? So the next piece of what we're talking about is right below that there's another box. And that box is talking about similar right triangles. So someone remind me, what were similar triangles all about? Absolutely. Same shape but different sizes. The angles are preserved, but the sizes of the sides are proportional. Okay? They have the same angles. The angles are congruent, but the sides are proportional. And we could prove triangles similar by angle, angle, or by angle, side, side, right? Or side, side, angle, right? And we could also use side, angle, side similarity, I believe. Okay? So when we're talking about similar right triangles, if we take a right triangle and we draw an altitude from the right angle to the hypotenuse, we end up with a total of 3 similar triangles. The 2 smaller ones are similar to the original. Okay, so we have a large triangle here, and a medium-sized right triangle, and a small right triangle. And all 3 are similar, but they're all discombobulated and twisted and rotated and reflected and so forth, so it's hard to kind of visualize how they work. So what we like to do is we like to take them and split them out. So do you see that if I pull that medium one out and that small one out, that we have 3 right triangles? And if I flipped this one and maybe reflected and turned it, and if I maybe reflected that one in some way and rotated, we'd end up with 3 triangles that are in the same orientation. Does that make sense? Okay, 3 triangles that we started with, or 1 triangle. We draw the altitude from the 90-degree angle to the hypotenuse, and that's making 2 small triangles. So if we pull those 2 small triangles out of there, now we've got 3 triangles, and they're all 3 similar. Okay, this is the hardest part of what we're doing today, and it'll become easier tomorrow. So there's 3 triangles. We have a large triangle. I'll draw that in blue. Okay, and then we have a medium-sized triangle that I'll draw in red. It's also a right triangle, and it's got this 90-degree angle here. And then our small triangle is this guy over here in green. Okay, so far so good? Okay, so they want us to write a similarity statement that deals with all three triangles. So one way to do that is to kind of think about which angles are in what. So do you see that this big giant triangle has an angle A? Isn't that the same angle as in the medium triangle? Okay, so I'm going to put a dot there. But now, which one is going to be congruent to that angle in the tiny green triangle? The one at B, exactly. So we'll put a dot here and a dot here. These two angles are equivalent. Okay. Now, in our big giant triangle, does everyone see that we have another acute angle called C? And C is also in the itty bitty, isn't it? But which angle would it be in the medium-sized triangle? The one at B. Okay, so we're going to put a dot there. Okay, so it's helpful to have colored pencils or gel pens or something to kind of distinguish things by color. Now, watch what happens when we pull these apart. So if I'm talking about the big giant triangle, the blue one, it's got this right angle at B, and it's got an angle at C, and it's got an angle at A. And this is my blue dot, and this is my red dot. Okay. Now if I redraw this red triangle, and I'm going to rotate it so it's in the same shape, my D is the one that's up here now, isn't it? You're going to have to be able to write a similarity statement. Now, not necessarily find the measure of those angles, but to find the similarity statement for them. And so we want to know triangle what is similar to triangle what is similar to triangle what. And we use the tilde instead of the congruent symbol. Okay? So here's our medium-sized triangle. D was the right angle. And the red dot, or the blue dot, is what on this medium-sized triangle? That's A, right? And then of the medium-sized triangle, the 90-degree angle is D, and the red dot is C. Everyone see how I turned that? You'll probably want to draw this yourself. Okay? Now let's get the tiny triangle. Okay? The tiny triangle has a 90-degree angle at D again. And it has a blue dot at B and a red dot at C. Now that they're drawn this way, can you see how easy it is to write their similarity statements? Because what do we want to call this one? The blue, what are we naming it? ABC, BCA, how do you want to call it? ABC. So if we're going to call this ABC, go ahead and grab it with blue. Then the red triangle has to be named what? A, C, B, right? Because ABC went from blue dot to right angle to red dot. So we need to do the same thing, A to D to B. And finally, our green triangle has to be called what? D to B to C. So if you can redraw those triangles in the same orientation that one of them happens to be in, that's going to help you. That makes sense? And putting a dot or an arc or something in those corners or in those angles can help you as well. So questions on this one? Okay. Everybody has your notes down? All right, here comes the next one then. Now, this is where it gets tough. You'll have two problems like the one we just did, just where you're redrawing the triangles and naming them by similar statements, making a similarity statement between those three triangles. But here's where it gets tough. And we want you to feel a little bit of pain, a little bit of frustration, so that you appreciate what we teach you tomorrow. Does that make sense? So if you come out of here today and you practice and it doesn't quite make sense yet, that's okay. We'll have a shortcut for you. But you don't appreciate the shortcut until you've struggled with the hard way first. Does that make sense to everyone? Okay. So we want to find the value of each variable. Okay? The best way to do this is to redraw those triangles. Okay? We're going to pull them apart and redraw them. Okay? So this tiny angle up here, right, is going to be in both the large triangle and the medium-sized triangle. And it's equivalent to this one in the small triangle. The angle down here in the large triangle is also in the small one, and it's equivalent to this one in the medium-sized triangle. Does that make sense to everyone? Okay. So we're going to redraw those triangles. Okay. So this one's just reflected. And the y was down here. It's now here. The whole hypotenuse of the large triangle is a total of 11. So that's the hypotenuse of our large triangle. And then we don't know anything about this side, so we leave it alone. We don't write any numbers down. This one did not have a side to it. But now look at our medium-sized triangle. When we take this 90-degree angle of this medium-sized triangle, kind of turn it, we have x for its base, 8 for its height, its altitude, right? And we don't know the hypotenuse of this one. Okay, it was the leg of our big giant triangle. And then finally we take that teeny tiny triangle and we rotate it. And so the 90-degree angle's down here. 3 was the smaller leg. X was the larger leg. And y was the hypotenuse. Everybody get them drawn on your paper? Okay. So now let's think about how they're related to each other. The 3 of the small triangle goes with the x of the medium-sized triangle. They're proportional. Does that make sense to everyone? The small leg, small leg. The longer leg and the longer leg are also going to go together. On the small triangle to the large triangle, the hypotenuse, y, goes with the 11, which is the hypotenuse of the large, and small to large, the leg, the smaller leg of the small triangle goes with the smaller leg of the large triangle. So far, so good? Okay. So here's how the proportion's set up. Nope. I didn't have a build for that. Okay, so let's set up our proportions. Do we want to find x first or y? X. Okay. So 3, if we go small to medium, baby bear to mama bear, right? Then we're saying 3 is to x as x is to 8. That looks like the geometric mean we were just working with, right? So when we solve that, what do we get? 24. X squared is 24. Is there a perfect square in 24? 4 times 6, right? The 4 comes out as a 2, and 6 is 2 times 3, so it doesn't have any more pairs, so it's going to stay inside, and that's our x. Okay. It doesn't. As long as you're careful to make sure that you're consistent. If you start with a small triangle and go to medium, then you have to go back to the small triangle and go to medium. So it doesn't matter which one's A or B, as long as you're careful. Okay? So now let's go with the big triangle, because we want to find y, don't we? And y is with the big triangle and the small triangle. So do you want to say small to large or large to small? Large to small? Okay. Large to small. My large triangle has a hypotenuse that is 11. What's the hypotenuse in the small? hypotenuse and the small is the y. Okay? Now, the other part I know is the shorter leg, right? So on the large triangle, the shorter leg is y. What's the shorter leg on the small triangle? 3. So now we cross multiply. We get what? 33 is y squared, right? And the opposite of squaring something is square rooting it. So what's y? Well, square root of 33. Does it have a perfect square in it? 3 times 11, both are prime, so we don't have to do any more. But redrawing those triangles really can help figure out what's going on until we show you the shortcut tomorrow. X was the 2 square roots of 6, because when we took the square root of 24, we had a perfect square in it. Twos came out, 6 stayed in. Okay? So far, so good? Okay. One more. Okay? So we're going to find the value of each variable again. And these are hard to visualize. If you get this today and feel really confident about it, bravo to you. Give yourself a pat on the back, because this is tough stuff. It'll be easier tomorrow when we show you the shortcut. Okay? So let's think about dots here. Of our large triangle, here's an angle, right? That's in the medium one. But of the small one, it's this little angle right here. Okay? In our giant triangle, this one is in both the giant and the small one, right? So where is it going to be at on the medium-sized triangle? By that 90-degree angle, right? So put a dot there. And then we're going to pull those triangles apart. Okay? So if we pull this big giant triangle apart, our long leg is x, our shorter leg is 6, and our hypotenuse on that one is 12. Got it? All right, so medium triangle, if we twist this guy, and remember, this is your right angle here, we have to flip it, don't we? Kind of grab it and turn it so that the 90-degree angle's down here. The shorter leg is the y, the longer leg is the 9, and the hypotenuse is the x. And then we grab this little one, and we just have to reflect it, right? So when we reflect this one, the 6 is the hypotenuse, the y is the longer leg. Where did this 3 come from? Why is this 3? Exactly. 12 is the whole hypotenuse of the large triangle, right? And so 12 minus 9 got us the 3. So you may have to do some addition or subtraction of something to figure out that last piece. All right, so does everyone see that we now have y's in the medium and small, and we have x's in the large and medium? So which one do we want to find first, x or y? X. Okay, so if we're working with x, we want to say large to medium or medium to large? Medium to large, mama bear to papa bear. Okay, so if we start with the hypotenuse of the medium, then we have to go to the hypotenuse of the large. And then if we go to the longer leg of the medium, then we have to go to the longer leg of the large. Bless you. Looks like a geometric mean, doesn't it? So when we cross multiply, we get what? 108 is x squared. If 108 is x squared, is there a perfect square in 108? That's even again. 27. That is not odd, even anymore, so 3 and 9. Yep. So what comes out? 6 comes out. What stays in? 3. All that time spent simplifying radicals, so it's easy. We're going to use them again in Algebra 2. Okay? Now we want to find y. So y is in the small and the medium. Are we going small to medium or medium to small? Medium to small. So we go to the medium triangle and we say, guess what? I have 9 for the larger leg, right? So we're going to call that 9. What's the larger leg on the small triangle? And then we need to find something else. So let's do small leg that has the y in it. Then we have to go back to the little triangle and say 3. So y squared is there a perfect square in 27? Okay, 27 is odd, so we try 3. 3 times tomorrow. Yep. 3 times 9, right? And then 3 times 3, what comes out? 3 squares of 3. Make sense? Redrawing the triangles really helps. Okay? You may be able to figure it out without, maybe using some dots or some angle marks and so on. But redrawing the triangles, I think, helps make sense of it. And then we'll show you shortcuts so you don't have to do the redrawing. Okay? So today, your assignment is just to finish the front side of this page only. I will. Yep. So just finish the front side. Back side is notes and assignment for tomorrow. Okay?